I have no idea if this is going to record because I'm using a different device. So for my group, we did the effects of different NaCl concentrations in the fermentation of glutinous rice. However, my stuff compared to their stuff is my stuff is way more accurate because I didn't use urine strip tests or pH strips. I instead used like a digital pH meter to record my data. So the numbers that you guys are gonna see are like two decimal places. So yeah, so we had 3 concentrations, each one salt concentrations. First one was 20%, second one was 10%, the other one was 5%. And we submerged rice in more of like a weight per volume. So we had, for me, because I cut it down by 10%, originally it was supposed to be 100 ml of water with 50 grams of rice, but then I made it 10 ml and 5 grams of rice. So we fermented that for 72 hours and then we recorded 0-hour pH and we recorded 72-hour pH, took the averages of those, and that became our results. For 5%, our initial pH, or my initial pH was 5.76. And for like 10%, it was lower, 5.66. And for 20%, higher concentration, the pH was also lower, 5.26. After the fermentation period of the glutinous rice, the one with less salt decreased in pH as more organic acids and CO2 was produced. So my pH was 4.84. For 10%, it decreased by a little bit, 5.58. And for 20%, it kind of increased or stayed the same. Honestly, guys, if my friends were to present theirs, I believe all the results are all the same. Like all their initials are all 5, close to 6, 5, 5. Mine are the only ones that have decimal places. Okay, moving on. So because this is like, we are unaware of like what bacteria is inside, so we are not so sure how the pH went down. Well, we can estimate, and I estimated by saying that one of the common bacteria found on the white glutinous rice was like Bacillus cereus. And in my conclusion, I indicated that that bacteria and its spores in dormant form was able to multiply in lower salt concentrations more rapidly than in higher salt concentrations, because the more salt there is in the aqueous solution, the slower or inhibited growth is depicted upon. And for this Bacillus cereus, its salt tolerance is 7.5% weight per volume of salt concentration. And since we only like incubated this for 72 hours at room temperature, which is actually within their optimal growing conditions, the incubation period, well, I don't know what bacteria there is, but their incubation period from 4 to 16 hours is 4 to 16 hours, and they have a doubling time of like 30 minutes. However, we didn't test how many cells there were left, or initial at all, so can't really say much. but we know for sure that for 5%, more organic acids and CO2 was produced than of 10% and 20%. Or scientifically, the explanation is in 10% and 20%, there was no fermentation whatsoever. Even though the results in 10% went down by a little bit, in my friend's results, since they're all whole numbers, this is kind of neglected. Like 10% and 20% has nothing. 5% is the real deal, where there was fermentation, and yeah, that was it. How do I stop?